SpaceX has been pretty clearly dominating the US launch industry. Last year, they flew over 60 missions. Their two major competitors, Rocket Lab and ULA, each flew just a fraction of that many times, with Rocket Lab flying 9 times and ULA flying 8. So you might be thinking, is anyone even close to competing with SpaceX? And what does the future look like? Will anyone be catching up to them? Because healthy competition does tend to drive prices down and lead companies to improve their products, and we all want to see better rockets flying. So what are they up against? What else is going to be flying in the next few years? And how will it compete with SpaceX? To start things off, I'd like to clarify that there are two different regimes for which rockets are optimized for. There are low energy missions, which are low and medium Earth orbits, and then there are high energy missions. These are missions which require a more capable rocket to send payloads out to geostationary orbit or even interplanetary trajectories. Now, while SpaceX dominates the low energy market, the rockets tend to struggle to reach those high energy orbits. For instance, the upcoming Viasat 3 mission to geostationary orbit require a fully expended Falcon Heavy. Now, what is able to handle those missions better are United Launch Alliance's rockets, such as the Atlas V, Delta IV, and soon Vulcan. These high energy contracts tend to be very lucrative because of the challenge in getting out there, and it's something which requires a purpose-built rocket to achieve, and trying to do it with something like Falcon 9 is going to be very inefficient. There are quite a lot of reasons for this distinction between low and high energy orbits and the rocket architectures that specialize in these, but that is enough to make a whole nother video on. For now, let's just look at what rockets have a chance at competing with SpaceX in terms of payloads to low Earth orbit. We're going to leave Starship out of the picture for now, because we don't know enough about it yet, and we don't know how much it's going to cost to fly. Some previous numbers have been in the $2 million range, but that is a very surprisingly low number, and it's unlikely that they would be able to achieve that. So we will have to wait and see how much it will cost to fly it, and how much it will cost to get payloads on board. Now, SpaceX's most well-known competition has to be Blue Origin, a company founded by Jeff Bezos. They have yet to demonstrate the ability to launch an orbital rocket. However, their in-development launch vehicle called New Glenn has similar lifting capacity to a Falcon Heavy and will be capable of first-stage reuse like the Falcon series rockets. They have already won a contract to send a couple of spacecraft out to Mars on the Escapade mission. And the value of this contract was just a tiny little $20 million, which is dirt cheap for a full dedicated flight of a rocket that performance class. For reference, Falcon Heavy is estimated at costing somewhere around $100 million to launch. Now, this price may be low because it will be the first flight of New Glenn, or at least one of the firsts, and as such there is more inherent risk involved in the flight, and that is probably factored into the cost. The problem here is that the New Glenn program has been notoriously delayed for many years, with the original targeted launch date of 2020, which has now since slipped into the fourth quarter of this year, and likely beyond that even. But once Blue Origin gets New Glenn online, it has the potential to compete with SpaceX quite aggressively in terms of cost for payload to orbit, as current numbers show it being able to carry 45 tons into low Earth orbit, which is a cost of 450 kilograms to orbit compared to a current estimated cost of $3,900 per kilogram on Falcon 9. Next up on our list is Rocket Lab's Neutron, which is an upcoming rocket currently set to fly at no earlier than 2024, although that number currently seems unlikely as the engine is still very early on in development and we really don't know too much about the current status of the overall rocket design. Neutron is currently listed as being capable of lifting 13 tons into low Earth orbit. However, there are no approximations of price as of now, so we'll have to wait to see how it competes. But based on the architectural decisions made with Neutron, we can expect a very low cost per kilogram on this, likely competitive with current Falcon 9 costs, if not significantly cheaper. Now let's look at Relativity Space, which just recently made their first orbital launch attempt, which was unfortunately a failure after the second stage engine failed to fully ignite. While the current Terran 1 rocket is not particularly competitive in terms of pricing, their next generation rocket, which they are currently focusing almost all of their resources on, the Terran R, will be a partially reusable design once again, which can carry 23 tons into low Earth orbit while recovering the first stage. We once again don't have any pricing estimates, but they are making some decisions in the design which should keep a low price, such as using prefabricated materials to build the tank structures of the rocket. They've also reduced the cost of designing and developing the rocket by getting rid of the planned upper stage reuse, which, while it's great to see, can be pretty expensive to develop. This rocket, I would expect to be once again competitive to the current baseline of the Falcon 9 in terms of pricing, but we really won't know until it starts getting NASA contracts with a listed value and starts flying. Now, this next company on our list is Stoke Space, and they have one of the most interesting rocket concepts that we've seen. Their goal is to develop a fully reusable rocket with a methane-fueled first stage and a hydrogen-fueled upper stage. Not only that, but the first stage will use full flow stage combustion engines, according to an interview with Everyday Astronaut. That is the same engine cycle as the Raptor from SpaceX, and it's incredibly complicated and challenging to develop, but it can pack so much punch that it's often worth the research and development costs of producing such an engine. Now, this is a very, very big goal for a company's first ever rocket. So we'll see how they do with achieving their goals. But currently they are developing a prototype of their upper stage, which will make test flights not unlike SpaceX's Starhopper or even some of the full Starship prototypes which made high altitude flight tests. They have a lot of unique design choices in their rocket, which could really improve the turnaround time between flights and even solve the heat shielding issues we've had on Starship. But pricing and also just seeing if it ever comes to fruition, all of that is yet to be seen once again. If they can achieve their goals, they have a good shot at becoming a major competitor to SpaceX, although their current mass to orbit is unknown, and it's a relatively small rocket, so we can't be expecting huge payload capabilities from it. And there's a few reasons for this, but small rockets tend to be more expensive per kilogram of mass to orbit when compared to a larger rocket, so they're going to have to do a really good job of keeping costs low if they want to compete with companies like SpaceX. although a big advertising point for them is that they can fly your payload to its exact orbit, whereas if you have a small satellite that you want to fly on a Falcon 9, your best option would be to put on a rideshare mission, where you just get dumped off on a standard orbit along with all the other satellites, and you have to maneuver to your final destination from there. Now, the last competitor on our list, but certainly not the least, is United Launch Alliance. They, before SpaceX, ruled the launch industry with the Delta II, Delta IV, and Atlas V rockets. They focused on flying to high-energy orbits, which allowed them to get lucrative military contracts. Now, the current Atlas V and Delta IV rockets are quite expensive and aren't well optimized for sending payloads into low Earth orbit. As a matter of fact, the Atlas V would cost $8,116 approximately per kilogram of payload into low Earth orbit. That is because the rocket didn't have much competition at the time it was developed, so cost wasn't a major concern. And then, once again, because it's designed for those high energy orbits, it's not as effective at carrying payloads to low Earth orbit. But ULA has a plan for that. Their new Vulcan rocket, which is once again designed for high energy orbits, will also have a specialized configuration for carrying heavy payloads into low Earth orbit. We don't know exactly how cost competitive this will end up being, but we know that Amazon's Project Kuiper, Starlink competitor, has chosen them to fly the majority of their missions, which is a good sign for the value of each Vulcan flight. Now, the way that the Vulcan is designed, the first stage of the rocket re-enters the atmosphere at a very high speed, and the upper stage accelerates quite slowly, so it needs to be moving quickly, meaning that Vulcan can't waste fuel on a propulsive landing or re-entry burns. And there just really is no way to bring down the rocket in one piece through re-entry at those speeds. So what they're going to do instead is detach the engine section of the rocket, deploy an inflatable heat shield, and just that will re-enter the atmosphere and be recovered by parachute in the ocean. This allows them to save a lot of money because they won't need to buy as many engines. And that will certainly help to lower their launch costs by a significant amount. Although, once again, we don't have any exact figures yet. But I think those are probably going to be SpaceX's biggest competitors in the near future. And how close the competition is remains to be seen, and a lot of it depends on how well Starship does. Which, as of now, we don't really know what it's gonna do after its mixed performance a few days ago. And with that said, thanks for watching, and have a great day.